In this video, I'm going to implement a simple machine learning project with the help of polynomial regression machine learning algorithm. What we'll do is that we'll try to create our small data set and we'll make sure that that specific data set will have a nonlinear relationship. And with the help of polynomial regression, we'll try to solve that particular model, or basically we'll create a model and we'll try to create some kind of best fit line so that it gives us good accuracy when compared to a simple linear regression model or a multiple linear regression model. So first of all, let's go ahead and let's do one thing over here. The first thing that I am actually going to do is that import some of the libraries. Okay, so let's go ahead and import some of the libraries. And obviously, first step is importing libraries, right? And everybody is familiar with that because from now onwards, like whatever thing what are libraries we basically install or import. So here import numpy as mp, import pandas as pd, and import matplotlib.pypot as plt, right? So this is there. And then what I'm actually going to do is that I see the type of data set that I really want to create. Let's imagine that I want to create a data set. Now, whenever I say my data is non-linear, like if I probably create this kind of data with x and y, so here I can say that, okay, it has some kind of linear relationship, right? But if I say, if I have some data points which are in this shape, let's say it is in this specific shape. So here you can see that some type of curves are there, right, in this data set. And what exactly this is nothing but this kind of curve in a data set we get basically from quadratic equations. And what is the form of quadratic equation in this shape? Ax square plus bx plus y is equal to 0. So this is a quadratic equation, right? And that is the reason why we use gradient descent in a specific, this gradient descent is also like whatever loss function we use, right? Like MSE. This is also coming from this quadratic equation. So that is the reason we get this. Now what I'll do is that we'll try to create this data point. Okay, like let's say this is my x and y. And for this, we'll try to see what happens when we create a best fit line like this. And after that, obviously here, the error, that we are going to see over here will be quite high, right? Once we create a best fit line. So we really need to create something like this as a best fit line. And this will only be possible with the help of polynomial regression, right? So with the help of polynomial regression, we'll try to see how we can create this kind of best fit line for this specific data set. So let's go ahead and let's quickly try to see, and anything that I probably have to write, I will be writing in front of you so that you will be able to understand. And definitely make sure that you can practice all these things, that you can also consider any kind of other data set which follows this specific pattern. So to begin with, what I'll do is that I'm just going to copy 2 lines of code from NumPy, which will actually help me to create my data set. So here what I have done is that in the X, which is my independent features, here you can see I'm using np.random.rand, that basically randomly we're going to pick up 100 numbers, okay, in this specific shape, 100 comma 1 and -3. So that basically means I just want to add some kind of outliers to this x-axis or x value by by subtracting with -3. And this, you can see this is a quadratic equation, right? Ax square plus bx plus c, right? Plus np.random is again an outlier. We are specifically trying to add some kind of outlier, okay? So here I can definitely write, this is my quadratic equation used, and here you have something like y is equal to 2x to the power of, sorry, it is 0.5 x to the power of 2, right? And then plus, that is nothing but 1.5x plus 2 plus outliers, right? So this is the format that we have specifically used in this, okay? And then let's go ahead and plot it. So I have already made sure that let's plot the matplotlib percentile matplotlib inline so that we'll be able to display these images in this Jupyter notebook, okay? So quickly done, right? Plot, see the spelling, okay? See the spelling over here, your spelling should be absolutely fine. So done. Now if I say plt dot plot on my x-axis comma y-axis, and let's say I'm going to use some green points just to plot it. Okay, and along with this I will say this will basically be my X labels. I'm just preparing my data set, guys, nothing so amazing in this, because we should definitely try to know how to create our data set just for testing purpose for any algorithm. Okay, that will actually help us to see something. So here it says plt.plot. Again, plot is not actually working. So what I'll do is that you can see the data points over here. Not need to use plot, we'll use scatter. Let's see. Okay, scatter. In scatter we don't give like this. We have to assign something like a color, and let's say here I'm giving red. Now here let's consider green one. Okay, red is too dark. Now, the data points that you see over here, obviously it does not have a complete linear relationship, right? Non-linear relationship is also there. You can see this kind of curve, okay? Now we will consider this particular data set and we will try to probably implement a polynomial linear regression, and we'll try to see, first of all, with the help of simple linear regression, if we try to implement, what is going to happen, and with the help of polynomial, how the accuracy is basically going to get improved. Okay, so after this, what I'm actually going to do, I'm going to do a train test plate. So I'll write from sklearn.model selection, because I really need to do a train test plate. So from sklearn.model selection, import train test split. Okay, then here you have x train comma x test, y train comma y test is equal to train test split, x comma y comma, here I'm going to specify my test size. Let's say I'm just saying 0.2, and I will be considering some random state. Let's see, random underscore state is equal to 42. Okay, perfect. So let's see what is the error. I think somewhere some error may be there. A random state. Perfect. Not a problem. If you are getting an error, don't worry. You just have to fix it by seeing the description. Okay. Then now let's implement a simple linear regression, right? So here from again sklearn dot linear models, whatever we have actually done in the previous class, import linear regression, and here I'm just going to say regression underscore 1. This is my linear regression, so I will just say linear regression, and here I'll be initializing. Perfect. Then finally we will do regression dot fit on my x underscore train comma y underscore train data. Okay, and we'll try to execute. Over here, see, you can also do scaling, but already the values that you'll be seeing, right, of x train and y train, it is almost in the basic scale. But if you really want to do, you can definitely do it. See, -2 1 0. So whatever initialization is basically done over there, right, it is based on normal distribution itself. Okay, so dot fit on x train and y train, and once we do this, here you'll be able to see this thing. Now what I'll do, from sklearn dot metrics, I'm going to import the R2 score, right? And finally I'll say score is equal to, okay, now we are going to use the R2 score just to calculate what is the score of the model. And here I'll say y underscore test comma, and then we can use our regression 1 dot predict, and I will try to predict my x test data, right? So that becomes my y pred, and finally I will just try to print the score. And obviously you will be seeing that you will be getting some error. So sorry, you'll be getting some less accuracy. Why less accuracy? Obviously because your data point is like this. If you try to create a best fit line, so obviously you're going to get a bad error, right? So let's visualize this image. Okay, let's visualize this model and how it is created a best fit line. Okay, so in order to do this, what I will be using is that I'll be using a simple plot function to just see that how the plotting is basically happened. So I can basically write plt.plot on x train comma, for the x train I really need to use my regression model dot predict on my x train data, because I'm just trying to see how the best fit line will come for the training data, right? And here I can definitely use some color. Let's say the color is red. Now we can use a dark color, that will be good. We can actually see it. And along with that, I'll also try to scatter all my x train and y train data, right? So now I'll just scatter this x train and y train data. Any default color can be used. And apart from that, we will also be writing plt.x label. So this will basically my x data set. And finally, I'll just say plt.label, and here this I'm just going to put it as y. Okay, and finally I'll just import it. Now see, matplotlib.pyplot has no attribute label. Y label, I have to use y label. Now obviously when you get this kind of best fit line, you're going to get a good amount of error, right? Now let's see how do we solve this problem with the help of polynomial regression. Now first thing in polynomial regression is that what we do whenever we have a polynomial regression, right? Let's say I have some data, right? Let's say this is my x data and y data. Right now x data is in degree 1, right? So I can probably take something like this. My h theta of x will be beta 0 plus beta 1 into x1. Right now this is what my model is all about, right? And obviously with this best fit line we are not able to get good model, good accuracy. So what I'll do, I'll say h theta of x, and I will increase this polynomial degree, and it will become something like this: beta 2 multiplied by x2 whole square. Sorry, it should be x1 only, not x2, because I just have one input features. So we will first of all try with this. If it does not work with respect to this, later on we'll try to create a generic formula wherein we just keep on increasing the degree of this x1 feature, right? Let's say I want to increase this again. This will be beta 2, then this will be beta 3, x1 of 3, right? So here, if I probably just show you, right? If I probably show you, right, over here, see. Okay, so here we will be using, or we will be increasing the polynomial degree. Okay, so that is what we are going to do it now with respect to all my features. I really need to increase the degree of the features and try to see whether my line will fit or not. Later on we'll try to create a common function which will do all this specific task. Okay, now how do I do this? How do I probably create a degree for 2, 3, 4, right? So for that in sklearn we have something called as, so here I'm just going to say let's apply. So here let's apply polynomial transformation. Okay, and here what we are going to do is that we are just going to write from sklearn dot preprocessing import polynomial features, right? And finally I will execute this, and here you will be also be seeing that I'll write poly. Now here this polynomial features is used for the transformation, like to increase the degree. Suppose if I have just x1 variable, if I say I want to use a degree of 2, that basically means x1 square will also be created as a new feature, right? So here I will be writing polynomial features, and finally I will be using degree is equal to 2. And here let me also say there is a parameter which is called as include bias. I'm also going to include the bias so that 1 will also get created, you know, first variable, right? So what do I mean by 1? Let's say I'm just going to write this equation. Let's say this is my first equation. I'm going to use this. I'm going to rub this. Okay. Let's say my h theta of x is nothing but it is beta 0 plus beta 1 into x1, then beta 2 into x1 whole square. So if I say degree is equal to 2, that basically means x square is created. Include bias basically means here it will be multiplied by 1. Okay, so we are going to take this 1, we are going to take x1, and we are going to take x1 square for our model training purpose. All these things we'll try to show it to you. Okay, so as soon as I probably transform this, you'll also be able to see that. Okay, now the next thing is that what I will do after doing this, I will say x underscore train underscore poly, and here I will be saying poly underscore fit underscore transform, and here I will be saying x underscore train. Okay, and similarly x underscore test underscore poly will be nothing but poly underscore fit underscore transform. Okay, on my x test data. Why do I write only fit underscore? Sorry, this should be not fit underscore transform. It should be poly dot fit underscore transform, and this should just be dot transform. Okay, so probably I've just written underscore. That should not happen. But again, I've already discussed why do we the difference between fit underscore transform and transform. I just want to apply this techniques in my test data. Okay, I do not want to make sure that again I create all the features again. So that is the basic difference over here. Why this is done? Because I don't want to know the information with respect to my test data. My test data should be completely new. So whatever technique is getting applied over here, that same technique with that same value of X train will get applied to the X test. So in short, what will happen if I just transform this automatically for this particular feature, degree 2 will also get created like x1 square. For this, in the same mechanism for this also it will get created. But there is a minute difference between fit underscore transform and transform. Fit underscore transform makes sure that the main data validation part from where we are actually trying to transform is my training data. No reference of the test data is basically taken. Okay. So this is super important for everyone. You really need to understand this. So let's go ahead and execute this. Now here you can see, now if I probably try to execute my x underscore train underscore poly, here is your data. So this became my 1, this became my x1, and this became my x1 square, right? If you don't believe me, open up the calculator. Let's see what I get from the calculator, right? Suppose if I say minus 2.7488, okay, whole square. So it is nothing but 7.5559, right? Which is approximately equal to this if I probably take up all the data points. So this is my bias. This is my x1 feature. This is my x1 square, right? So degree, polynomial degree as 2. Okay. So this is what I have done. And similarly, you can also check it for x underscore test or underscore poly. Now, once you have this particular data set, all you have to do is that try to apply the same linear regression, whatever we did, right? So I'm just going to copy this because it is almost the same thing. And then we are going to probably see it. Now here you can see that since the batch parameter is already included, we have taken linear regression. I have used x underscore train underscore poly, y train, and then we did a prediction. And right now, before the score was what? My score was 0.62, right? Now you see the score. Whether the score will improve or not. Yes, I think it will improve. Now you're getting 0.9393, which is quite amazing. Now you may be excited, Krish. How's the graph getting created? You can obviously see from this model, right? If you probably see one more thing, if I write regression dot coefficient, here you'll be able to see 3 coefficient. One is 0, one is 1.5, one is 0.5090. Why? Because I have 3 features now, right? Before I just had 1 feature, right? This is super important to understand. But with respect to intercept, I will just be having 1 feature. So here I'm just going to write intercept. I will just be having 1 feature. Perfect. So this is quite amazing, guys. We are able to get it. Now comes the main part. You can obviously do the prediction. You have also seen that with the help of prediction also, when I'm seeing it is coming as 93%. Now let's take some new data and let's try to plot this, or just before this, let's plot this one. So I'll say plt.scatter and let's plot my x train, okay, x train, comma, the prediction that I did it for, or I can basically write something like this. Regression. This regression is basically my polynomial regression, okay, dot predict, okay, and I am going to predict my x underscore train underscore poly, okay, and once I execute this, here you can see this, right? See this curve. So this is my best fit line that is coming for all these data points. And if you also want to see the other data points, all you have to do is that just write plt.scatter, okay, and here you can probably take x underscore train, y underscore train, okay. Now once you plot this, now see, for all these data points, this is how your best fit line comes. So that is the reason why you're getting such an amazing accuracy, okay, such an amazing accuracy. But now the question rises, Krish, what if I make this degree value as 3? Just let's consider, okay. So let's see, if I make this degree value as 3, then what will happen? We also need to think about that, right? So if I make this degree 3, will my accuracy keep on increasing? Again, I will copy this. I made it as 3, and then I will probably just try to see x train first of all, right? So if I write x train underscore poly, what do you think we'll be having? And now I have 4 features, right? 4 features. Now this is nothing but, it is just imagine that here you're just trying to find out the cube of that, right? This to the power of 3. Right? So same thing here you are able to get. Now what I'll do, I will apply the same thing and let's see whether the accuracy will increase or not. So here for degree polynomial, I'm getting 0.9343. Before I used to get how much? Okay, just a second for this x test pro x train poly. So here x train poly y train, this is my x train. Yeah, I'm getting almost same accuracy, somewhere around 0.9343, right? So before that, what was the accuracy that I was getting over here? After applying this, see the accuracy is downwards here, 0.9393. So just a minute difference, right? But yes, I can definitely say that the previous one was working well. So I may probably just consider degree is equal to 2. But sometimes you may be having a data set that will be having too much different type of nonlinear relationship. Now let's go ahead and try to see the prediction for the new data. Okay, and this is super important, guys. Prediction of new data. Okay, new data set. Now, first of all, what I'm actually going to do, I'm going to probably take a data. Okay, take a data. So as soon as I get a new data, let's say I'm getting this new data with length space this, and I'm reshaping to 200,1. Let's say this many data points I'm actually coming as a new data point. First step I'll do poly.transform on this new data. So here I will be getting a new polynomial feature. So in short, if my degree is 2, okay, I will be getting 2 features, that is 1 x1 square. If I probably take 3 when I was actually creating my polynomial features, then it would have been how many degree of polynomial would be 3, right? Now in this particular case, if I probably go and execute my x underscore new underscore poly, here obviously what you'll be able to see, you'll be able to see 4 features, right? Because the degree of polynomial is 3. 1 is the bias, right? And remaining all you are able to see over here, right? Very simple. Now what we are going to do, we are going to just use regression.predict. Now this is super easy, super important. So I'm just going to copy and paste the code. Plot x new, x train, y train, x test, y test. Y new is the predicted for the new data points. And when I'm predicting this, I'm also plotting x train, y train and x test, y test. And once I see this, guys, see this curve, amazing, right? I'm actually getting this entire predictions along with the green points here and there and blue points here and there, right? So this is how we are able to see this. So here I'm just going to write new, this is my training points, yeah, obviously, and new prediction I'll write over here, right? So this is how we are actually able to see, right? This is for the new data set. Now see how my model has got trained for this kind of similar data. Okay, so this is so super important with respect to this. Again, you can try with different polynomial degrees, whichever gives you the best performance, you can basically take it up, right? So I hope you like this particular video. And yes, this was it. In this video, we have focused on implementing polynomial regression. Yes, I will see you all in the next video. Thank you.